Hi guys, how are you? I hope you are alright. I'm very good here. I want to speak to you a little bit about performance this time. This is the continuum of this series of videos about flight prep, and the last one I spoke about, I think, NOTAMs and basically, yeah, NOTAMs. So this one is going to be about performance, how to do it, where do I get the information, and well, and without further ado, let's go to it. So first of all, let me show you how you can access your performance tables and everything. So basically, first of all, you have to come to SEPA, okay? And why am I at SEPA? Because I want the aircraft flight manual, so I can go to the performance part. If you have already the aircraft flight manual and you don't need to come here, we can skip this part. But if you don't have the aircraft flight manual and you have SEPA access, which is our program to check for manuals and everything, you'll just need to come here, manuals of the school here, and you'll go for publications, airplanes, and then in our case Cessna 152, and just you have here the POH, just download it. All right, I already have it here, and we'll come to performance. All right, you'll have a slight introduction, and then they will explain to you how to do the performance calculations, but I'm going to skip this part. Also have airspeed calibration, temperature conversion, stall speeds if you want to check them out, and then we'll come here. So first of all, when you come here for the takeoff distance, basically with the performance, with performance we want to check four things. So first of all, can I take off from the runways I want to take off? Cruise performance. How do I want to cruise? Do I want to cruise fast and have a higher fuel consumption, or do I want to cruise slower with the lesser fuel consumption? And third, can I land at the aerodromes that I want to? And finally, do I follow the ICAO prerequisites so ICAO limitations due to air law in all of those runways? So, first of all, as I was showing you, to know if I can take off from the runway that I want to, I'll have to come here to these charts, of course, for takeoff distance. And the first thing that you will encounter is that basically it will ask you for the pressure altitude that you're at. So first you'll need to know your pressure altitude. And how do we know this? Okay. Um, let me first of all show you. So I'll have a document here already done, and if you look at this part here, so the first thing that I went for was the QNH. All right, so QNH is 1016 hectopascals, and why? First is important for you to know that pressure altitude is the altitude. If you don't remember, it's the altitude that you are in relationship with the 1013 isobar. Okay, 1013 hectopascal isobar. So in order to know this, you'll need to know the QNH, which in this case was 1016 hectopascals. Where did I looked for it? I went to see, I'm assuming that I'm going to fly tomorrow at 8, so I went to Met Office and I got 6 a.m. chart. As you can see here, we have here the 1020 isobar, 1016, so I assumed 1016 because it's the worst case scenario for me. And then I also have the middays chart, okay, which is also the same thing, 1020 isobar, 1016 isobar. Again, worst is 1016, so I'm going to use 1016 hectopascal. But why the hell am I paying so much attention to this isobar here? So I'm going to use my friend Paint to explain it to you, all right? So first of all, let's say that this is Qashqai, okay, this is the ocean, and we are here, right? Yay, okay. So we want to know our distance so our altitude in relationship to the 1013 isobar. So how do I know and how do I relate myself with this isobar? Well, now I can, because I know that is an isobar here at mean sea level. That is what? 1016 hectopascal, right? That's what we saw in the other chart, okay? So this is the 1016 hectopascal isobar. So the 1013 isobar has to be upwards, right? Because lower the altitude, lesser the pressure, right? So I know that the 1013 hectopascal isobar, it's a little bit up, it's a little bit above mean sea level, okay? And what I want, pressure altitude, so I can use it on my graph here. What I want is the pressure altitude, which is basically my altitude in relationship to 1013 isobar, okay? So what do I know? First of all, I know that my altitude in relationship with the mean sea level, that is where this isobar 1016 is, it's 320 feet approximately. So if I know this difference here, okay, if I take the 320 and I subtract this distance, I will have this altitude here. That's what I want, okay? So it would be great to know this. How do we know this? Well, we know that for each hectopascal, this is equivalent to 27 feet. So now it's basic math, okay? So I know that this is a 3 hectopascal difference, right? So 3 hectopascal difference. So now it's a basic rule. So you multiply 3 by 27 and basically that's your result, and you'll have this altitude here. You subtract it to 320 and you have your pressure altitude, which is what I did here. So the difference was 3 hectopascals, okay? 3 hectopascals times 27 gives you 81. So this is 81. It's, sorry, where is paint? It's this difference here, it's 81. Now to 320 you take the 81 and you have this altitude. That is your pressure altitude, okay? And our pressure altitude is, so end of the day, 239 feet. So now when I come to my whoops, why can't I access it? Okay, so now when I come to my graph, I already know that I'm going to use 239 feet, which is closer to sea level. So now we'll just have to, we have the pressure altitude. We'll need to discover the temperature. Okay, how do we do this? Basically, like old ladies do, we just check the maximum temperature for the day ahead. All right, so I go for tomorrow, and I know that for me it's gonna be somewhere like 24 degrees Celsius, as you can see here. Okay, so with this I can go to my graph, and I know that it's pressure altitude sea level, and I have 24 degrees Celsius, which is between 20 and 30, and I'm going to consider 30 because I want the worst case scenario for me. Alright, but I didn't highlighted these values. I highlighted these ones. And why? Because if you check here, this is takeoff distance for the short field, which means that when you're going to take off, you have to have your feet in the brake, full power, and then just release it, and you'll have to be with flaps 10. We usually don't do this, okay? We just perform regular takeoff. So, but these distances are for takeoff distance. So this is an intern procedure. We just choose, instead of these values here, we choose one line down and one column to the right. Okay, so instead of sea level 30 degrees Celsius, we use 1040 degrees Celsius to compensate for, instead of short field, we just do a regular takeoff distance. Okay, and this will give us these values. So now I know that my ground roll is 1010 feet, and takeoff distance distance to clear 50 feet obstacle, it's going to be 1859 feet. So, but I cannot only know these values. I have to know if I can take off from the runway that I intend, which means, okay, how long is the runway? So that's why you have to go to what? To your you have to go to your aerodrome's charts, okay, to check the takeoff runway available and check the distance. This is in meters. I passed it to feet. All right. And now we know that we need to take off and clear a 50 feet obstacle, 1859 feet, and I have available 4428 feet. So I'm going to need approximately 42% of the runway, not the takeoff distance available, because we still have a stopway and a clearway, but I'll just need 42% of the runway to reach 50 feet in my takeoff. Okay, this is very important. Then, once we move on from takeoff distance, we'll reach, sorry guys, just let me put this straight. All right, rate of climb, okay, and rate of climb will be for us 630 feet per minute and 535 feet per minute. So 630 during takeoff and 535 during en route climb. All right. So before passing to cruise, still talking about takeoff, I wanted to go backwards a little bit and talk to you about density altitude. This is not, you are not obliged to do this, okay? But it's not mandatory, but I like to do it. All right. Basically, density altitude is the altitude at which your aircraft would behave if it was in an ISA, in an ESA atmosphere. So tomorrow we are not going to be in ESA atmosphere because it's going to be 24 degrees Celsius, which is hot. Okay, so for tomorrow we are going to take off as if during an ISA temperature day, we are going to take off and have the same performance as if we were taking off from an aerodrome at 1,300 feet, okay, approximately. How do you calculate this? So 24 degrees Celsius, the difference from 15 degrees Celsius, which is the ISA number, it's basically 9 degrees Celsius. For each degree Celsius, we assume 120 feet difference. Okay, so 9 times 120 will give you 1080 feet. So you're gonna take off as if you were 1080 feet above what you're actually taking off. Since our pressure altitude is 239, we'll just add up to 1080, and we have a density altitude of 1319 feet. We are taking off with the same performance as if during an ISA temperature day